Imagine you have two beakers filled with equal amounts of water, and they are both connected to each other by a pipe at the bottom. If you observe the two beakers for a few seconds, do you think the water will flow from one beaker to another? No, you will see that the water in both beakers is as is and there is no flow from any beaker to the other. Now let me give you a task. Without changing the amount of water in any of the beakers, can you make water flow from beaker 2 to beaker 1? Understand my question again. You need to make water flow from beaker 2 to beaker 1. But you're not allowed to change the amount of water in any of the beakers. So you can't add or remove the water from any beaker. How will you do it? It's easy. One of the things you could do is raise the height at which the second beaker is kept. Once it's raised at a height, the water will flow from beaker 2 to beaker 1. What exactly happened here? What was the factor that made water flow? In simple terms, the factor was height. Yes, you can talk about gravity or pressure difference. But in layman terms, it is the height difference that causes the water to flow from the second beaker to the first. In an exactly similar way, for electricity to flow, there has to be some factor. We'll come to that factor soon, don't worry. So if we just have a copper wire, do you think electricity will flow through it? Clearly not, because there's nothing that's triggering it. There's no factor triggering it. So what is the factor that triggers the flow of electricity? It's called the potential difference. Now I can define this term in one line, but that wouldn't help you understand the concept well. So let's dive a bit deeper into it. We see the word potential here. Have you heard this term before? Of course, we've heard of potential energy. It is the stored energy when an object is at rest. When you're holding a ball in your hand, it has potential energy. When you drop it, the potential energy is getting converted to kinetic energy when it drops to the ground. Kinetic energy is the energy an object has when it's in motion. Similarly, there is a concept of electric potential energy. The electric potential energy of any charge describes how much stored energy it has. Just like the ball in your hand has high potential energy, a negative charge close to another negative charge has high potential energy. If left free, the charge will be repelled by the negative charge and will move towards the positive charge, just like the ball will fall towards the earth. What's potential difference then? It's just a difference of electric pressure between 2 points. And this difference may arise because of a battery consisting of cells. Potential difference is also referred to as voltage. If we have to understand the technical definition, we would say that it is the work done to move a unit charge from one point to another. The potential difference V between any 2 points in an electric circuit will be the work done over the charge Q. We know that the work is measured in joules and charge is measured in coulombs. What's the SI unit of potential difference then? It's volt, named after Alessandro Volta, an Italian physicist. So how would we define volt in a current carrying conductor? It is the potential difference between any 2 points when 1 joule of work is done to move a charge of 1 coulomb from one point to another. The potential difference is measured by an instrument called voltmeter. It's measured in parallel across the points between which the potential difference is to be measured.